Hey guys, we're going to look at an example for 4.5 rational functions. And our example says for us to graph this. Well, we're not actually going to graph it. How your homework will be was it will give you a rational function and it will say select the correct graph. So what I'm going to do is I'm going to show you how to find the critical information to help you discern which graph is correct. And then what we're going to do is we're going to take our information and validate it by looking at a graph of it on Desmos. So first thing that I would do is I would find my vertical asymptotes. Okay. And for that I use the denominator. And all that means is that I'm going to find the zeros of the denominator. So with that I say x squared plus 4x plus 3 equals 0. And then I factor. So, and I set each one of them equal to 0. And these are actually equations. I'm not converting these to points. These are my vertical asymptotes. These are lines. Okay, these are lines. So these are equations. Remember, they're lines, asymptotes. Okay, so the next thing I need to do is I need to determine, can I have a horizontal asymptote with this? And yes, I can, because my leading terms have the same degree. My leading terms have the same degree, so I can have a horizontal asymptote. Goodness gracious. I can have a horizontal asymptote for this. And for whenever they have the same degree, I use this. Where A is my leading coefficient in the numerator and B is my leading coefficient in the denominator. So that one's an easy one. I end up with 1 over 1, which equals 1. So my horizontal asymptote is simply y equals 1. This is an equation also. These were vertical lines. This one is a horizontal line. So this is an equation. It's a line. Okay. Next, what I'm going to look at is I'm going to look at the zeros of the function. And for that, I use my numerator. That's how I find out where the zeros are. So I take my numerator and I set it equal to 0. And then I factor. So what I end up with, and these are going to be coordinates. These are 0 coordinates. So whatever x value is and then 0. Okay, but I need to point something out though. I need to point something out for us is that notice here x equals a negative 3. These are, sorry, I'll go ahead and do those. But what I need you to see is that x equals a negative 3 is also here with x equals negative 3. I ended up with the same factors in the numerator and the denominator. This is an important concept. Whenever that occurs, I no longer have a vertical asymptote at that spot. And that's no longer considered a 0. So what this turns into is a discontinuity. So whenever I have the same factors or zeros in the numerator and denominator, then there is no asymptote No asymptote. It is now a discontinuity. But what we need to do, see for this one, it's going to be a -3. That's my x value. But I don't know what my y value is. It could be 0 since it's at a 0, but I'm going to have to be able to find this value. And I'll show you how to be able to do that. And here, to remember what a discontinuity is, just in case, that's where we have the open circle in a graph that goes along. We looked at it when we were looking at domains, piecewise functions. Okay, so that is the zeros of the function, and you always have to compare your factors between the two. And then I can find y-intercept, and that's simply where I plug in the value of 0 for x. Y-intercepts are simple. It will just be my constants because I'm plugging in a 0 for everything that's an x. So everything goes away, and I'm left with simply this. And my y-intercept, this is a coordinate. What I'm saying is x is 0 and this is a -1. Up here this was 1, 0. That's my y-intercept. And then the last thing that I need to do is I need to just look at other points. I need to plug in some x values and get y values for it. And that depends upon what your function is and what your graphs look like, what values you choose to pick. Uh, so arbitrarily just writing some down to offer you a visual aid. You'll plug in these values, you get subsequent y values or f of x values back. Okay. Well, I've done that for us for this example for us to be able to save time. I've used Excel to be able to put them in, so we're going to talk about those. So let's look at Desmos, okay? And here, I'll take those off right now. This is my function in blue. It's my rational function. My vertical asymptote is x equals a -1. My horizontal was y equals 1. So let's pull up our points. Step number 5 where I said just select some points. So what I did is some of these I already knew from what we did in our work, all right? But others I just plugged in, and I use technology just to be able to save time. So very quickly, at where my pointer is, that's a -5, and it tells me my y value will be 1.5. So I'll go up here, and yes, that is 1.5 because this is 1 right here. Halfway between 1 and 2 is 1.5, so -5 and 1.5. And I can go along each of these x values and be able to look as we move through. Here at x equals 0, y equals a -1, that was the only 0 that I had. At whenever x equals whenever x equals 0 or y equals a -1, that's my y-intercept. Whenever x equals 1 and y equals 0, that's my only 0 that I had on there. This was my y-intercept. Okay, so all of this makes sense. So to go to our two, and the UND means undefined. So we're going to go to our undefined portions. That will be my discontinuity and my asymptote. The asymptote we already looked at. Undefined, well, Desmos doesn't just give me that circle right here. Okay, it actually completes the graph. And some of your graphing platforms, they won't be able to graph discontinuities, and that's fine. It takes a lot of programming in there, a lot of algorithms to be able to do that. So we have to understand that there is an open circle right here at a -3. From our graph, we can tell what the value is. We couldn't plug in a -3 into our function and be able to solve for it. But I'll show you how you actually do that in a roundabout manner. And the basic premise is like what we're going to look at here for the asymptote. We know our asymptote is x equals a -1. So For my x values right here, you can see that I'm approaching from 0 to a -1. So as I'm going along the x-axis this way, it's giving me my y values going down to here. As I'm approaching from 0 to a -1, my values are becoming substantially larger negative. And if you look at the graph as it goes along, it takes off and it is heading toward negative infinity, but those y values keep getting larger and larger and larger the closer I get to a -1. The opposite can be said as I'm leaving -1 heading toward a -2. So I'm at -1 and I'm going toward -2. If you look at our numbers, I have very large positive numbers and they're slowly decreasing as I go along until I get down here in this area, and then my numbers start to trail off. But this is almost like an exponential decrease, and this right here, we could think of it as an exponential decrease because my numbers are growing significantly more negative as I move along. Well, the same can be said for my discontinuity. So let's say I didn't have my graph to be able to tell that discontinuity's point was a -3, 2. I could start looking at numbers as I approach -3 from the right. So starting over here at a -2.5 and moving toward 3, whenever I look at my values, what are those values slowly approaching? 2. And then on the left side of a -3, so at a -3.5 moving toward 3, you can look at it and you can see that I am slowly approaching 2. This is a premise in calculus in which you deal with limits. Limits is very much like a discontinuity. Okay, so that is how you're able to tell what is the actual value of that discontinuity. And it shows you how your graph goes along but never touches that asymptote, the vertical asymptote. And these are just basic values that we determined through there plus some that I filled in. So I want to reiterate what we did. First thing we did was we found the vertical asymptotes by setting the denominator equal to 0. Then we looked to see, can we have a horizontal asymptote? Remember, I can only either have one horizontal or I can have one oblique. I cannot have multiple. I cannot have a horizontal and an oblique. I cannot have two horizontals. I cannot have two obliques with the problems that we're working. Okay, but specifically for horizontal, only one. Okay, only one. The next thing I do is I find the zeros of the function and I use the numerator. Then I need to compare the factors. Do I have similar factors from the numerator and the denominator? If I do, I no longer have that 0 and that vertical asymptote. I have a discontinuity. So I have to make sure that I label that and be able to see. And just so we point this out, that's the explanation behind what we did up here for here and for here. The next thing that I did was I found my y-intercept, and then the last thing is I find other values of the function. Pick an x value, plug it in, and find the corresponding y value. Okay guys, please watch the publisher's videos, critically think and structure your homework, and good luck with the rest of your homework.